Warning: sulfur dioxide is toxic and irritating. Sulfur trioxide is toxic, irritating, and extremely corrosive. Perform the entire experiment outside while wearing a respirator. Hi guys, here is MIH. The most viewed video on my channel is my success on the oswald oxidation to make nitric acid from ammonia. Since then, many people have suggested me to take a shot at an analogous process, the contact process, known to produce sulfuric acid and sulfur trioxide from sulfur dioxide. However, not a lot of details can be found on how this conversion would work. So I basically tried through a few designs and went through a decent number of failures. For example, here's me soaking molecular sieves into ammonium chromate solution and heating it up to obtain chromium oxide loaded on molecular sieves, which should have a larger surface area than chromium oxide alone. I tried passing sulfur dioxide from burning sulfur through the catalytic chamber, but nothing really happened. After a few more failures on trying to burn sulfur to obtain sulfur dioxide, I realized that the combustion is too unreliable to start and run, and generates a ton of sulfur vapor along the sulfur dioxide stream, which was extremely annoying. So, for my next design, I switched to generating sulfur dioxide from sodium metabisulfite and sulfuric acid. The downside of this is that we're consuming an equal amount of sulfuric acid as we may be generating, so we cannot produce sulfuric acid from this. But since I also wanted to make some sulfur trioxide, I thought that this is also okay. First, I prepared the catalyst using the same fashion in my nitric acid video, heating ammonium chromate until full decomposition. The yellow solid slowly turns black and green and releases a bunch of gases, including ammonia, nitrogen, water vapor, and maybe some ammonium chloride. After this initial decomposition, I loaded the catalyst into a quartz tube and heated it with nitromire while blowing air through it to fully decompose it and force out any water vapor and ammonia. When no more fumes can be seen at the outlet of the tube, the decomposition is done and the catalyst is ready. Meanwhile, the setup consisting of a pump and a 3-nick flask was constructed, and I generated sulfur dioxide by mixing sulfuric acid with sodium metabisulfite. I turned the pump on, and after a few seconds of feeding, a thin white fume appeared at the end of the quartz tube. I tested this fume using a pH paper, and the paper turned black as it carbonized. Only sulfur trioxide can have this effect. Of course, the effect may also be due to the very high temperature of the gas coming out, but I still think that this setup did work. With this test of theory done, I designed a much better apparatus using a 500mm long and 10mm diameter transparent quartz tube obtained from an infrared heating element. I first wrapped some nichrome and tested the heating. Since I'm using a 12-volt power supply this time instead of directly connecting to 220 volts like last time, the power is much less than before, and I'm worried that the operating temperature of 400 to 500 degrees C cannot be reached. But I eventually reached 410 C without insulation, and with insulation the temperature could certainly go up beyond 500 C, so we're all good. I prepared the chromium catalyst in the exact fashion. Note that the catalyst should be prepared right before the experiment. I haven't tested the effects of reusing the catalyst since I have a lot of ammonium chromate precursor. After some heating, I get this black-green powder. I filled the catalyst into the quartz tube and secured it with 2 pieces of aluminum silicate wool. The amounts of wool should be enough to hold the catalyst firm from the airflow, but not too much to block the airflow and create a pressure. I tested the airtightness of the apparatus by turning on the pump and passing air through the flask filled with water. Because I have to break the quartz tube to remove the filament originally inside it, the 2 ends of the tube are not smooth, and an airtight seal cannot be easily created, which was quite annoying. However, infrared heaters are probably the cheapest and most cost-effective way of obtaining quartz tube, as this heating element only costed me 15 yuan or $2, so I'm going with it anyways. I then finished the catalyst preparation by turning on the filament and passing air through the catalyst. As you can see, a lot of water is released. For nitric acid production this isn't an issue, but sulfur trioxide is extremely sensitive to water, so all traces of water must be cautiously removed, for example using a blowtorch. After all these preparations had been finished, I filled the flask with a random amount of sodium metabisulfite and added a little bit of 85% sulfuric acid in the dripping funnel. I generated sulfur dioxide by slowly dripping in the acid, and soon we can see some dense fumes forming at the end of the quartz tube. In my personal opinion, the fumes this time was much more apparent than the test run, but still not as strong as the sulfur trioxide fumes seen in many other videos. But they probably have more concentrated sulfur trioxide than me, and as of my knowledge, nothing can fume like this except sulfur trioxide. So I'm pretty sure that the setup worked, and I made some sulfur trioxide. However, the main skepticism I held was that this sulfur trioxide can be collected. I tried passing the gas through water, but the fumes simply carry on. There wasn't a super vigorous reaction that I expected, but the water also didn't get significantly acidic. I then added more sodium metabisulfite and sulfuric acid, and this time I tested the corrosive nature of this gas by passing it on a piece of tissue paper, but the paper only got slightly charred after a few seconds. This certainly doesn't fit the normal behavior of sulfur trioxide, as it was reported that sulfur trioxide instantly carbonizes any organic material within a second. I think the main reason behind all this is that the sulfur trioxide is diluted with a lot of nitrogen and leftover oxygen from the air, and the nitrogen flow sort of carries it along things and greatly diminishes its reactivity. However, I was still able to collect some significant evidence that we're making sulfur trioxide. One evidence was that the inside of the quartz tube was coated with a slightly oily liquid after some time, which could only be sulfuric acid formed from residual water. A more rigorous setup would include a drying tower between the sulfur dioxide generator and the quartz tube to get rid of all water, but I didn't bother since this was not meant for full-side production yet. The other fact I observed was that the fuming diminished when I switched the absorbing liquid from water to 85% sulfuric acid. Passing the gas through water resulted in very dense white fumes that easily escape the beaker and can be visible in a far distance. But with the sulfuric acid, the fumes were much thinner and didn't really escape out of the beaker. As sulfur trioxide reacts with water to form acid mists, but dissolves relatively well in 85% acid, this acts as another confirmation that we made sulfur trioxide. Of course, using concentrated 98% acid to absorb the sulfur trioxide is obviously more efficient and, to be honest, necessary if you're replicating this process. But anyways, that's all I've got for the process now. I still need to optimize the process regarding the collection of sulfur trioxide, but at least another amateur-friendly route to access sulfur trioxide is documented. I would love to hear your suggestions on how the process can be improved. See you soon!